Whew! Only a couple more examples to do. Thank goodness. I'm starting to get cotton mouth from talking so much. All right, for example 9, here you have to find your domains. Remember, these are your x values, not your y values. So when you're trying to find your x values of a function, whenever you have log functions, remember you have a vertical asymptote at x equals 0. And that doesn't matter if you have natural logarithms, regular logs, common logs, log to the base 5. It doesn't matter. You always have a vertical asymptote at x equals 0 unless there is a shift. And this would have to be a horizontal shift in order to change your domains. So if you have just your normal natural log of x function, then your domain in this case is just from 0, not including 0, all the way to infinity. Because according to your graph, when you plot a natural log of x, you just get this graph that goes along here. It comes down, doesn't touch 0, but because these are such big dots on the resolution on your calculator is not great, you can't just see it going down, then your x asymptote, or your vertical asymptote, is here at x equals 0. So what we're going to do is, maybe we're going to have this minus 3. Well, what's a minus 3 do to your vertical asymptote? Well, it should shift it to the left 3. So if we go to our function, and if we type in our graphing calculator, type in natural log of x plus 3, that's a horizontal shift to the left 3. We should get a graph that's over here on the left here. Now this graph stopped here. It's only because the resolution of your calculator doesn't let it go on, but this does keep going down, 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 down. So in this case, you get your vertical asymptote shifts to the left 3, which means that your domain is going to be from negative 3, not including it, to infinity. Now 3 minus x, that looks a little different. So what we actually have here is, if you have a negative in front of your x, that's the same thing as saying natural log of negative x plus 3. You can look at this a couple different ways. Let's look at it graphically first. So if we go to our y equals, I'm going to delete our second graph here, and I'm just going to put in 3 minus x. See if you have an idea of what might happen ahead of time. Graph it. There's our first one. Oh my gosh. Oh my god. Oh my god. Oh my god. Oh my god. That shifted it and reflected it. So this equation, actually, if you factor out an x, or a negative 1 from here, that would give you a natural log of a negative 1 times x minus 3, which means you would have a shift to the right 3, and you have a reflection. So actually, I didn't want to put that outside the parentheses. What I have is, you have a reflection, and it's inside your function. That means it reflects over your y-axis. So you are going to end up and have your domain from negative infinity all the way up to, and not including, 3. So your new domain, negative infinity, all the way up to 3. And that is just by taking out a negative 1 and looking at your shifting. Alright, so now let's do the natural log of x to the third. So if we go back to our y equals, and here clear this out, we're going to have the natural log of x to the third. Anybody have an idea what might happen here? Oh, I do, Mr. Klein, I do. Well, just hold your horses there, student. I know you're excited to give out the answer, but we gotta wait. Share and share alike. So let's graph this. There's our first parent function. Hey, if you have x to the third, it doesn't shift it anywhere. You're not shifting left or right or up or down. You still end up and get the same domain from 0 to infinity. Nice job, student. Oh my gosh, Mr. Klein, you're the smartest man alive. Thanks. Keep the cheering down. Thanks.